In this section, we're going to take what we've learned about stoichiometry and start applying it to the world of solution chemistry, specifically if a reaction is taking place in water. I kind of introduced that at the beginning of the chapter, that a lot of chemical reactions take place in solution where the water is the solvent. So let's define some terms to begin with, okay? A solution is just a short word for saying the same thing as saying you have a homogeneous mixture. We defined homogeneous mixture in chapter 1 when we were classifying matter. Homogeneous and heterogeneous were categories of mixtures. So when we say we have a solution, that is a homogeneous mixture. Now, solutions are typically made up of what we define as two other terms, the solute. Now, if you're mixing things together, one of those things you're mixing together will have a lesser quantity to it. That would be your solute. And the one that has the greater quantity to it would be the solvent. So in this chapter, as we talk about solutions, we're going to focus on the solvent being water. In every example that we look at, the solvent will be water. And when the solvent is water, we call this an aqueous solution. So we're going to examine the world of aqueous solutions, and we're going to kind of divide it up into several portions as we go through the rest of this chapter. The first portion in this section deals with concentration. There are a whole lot of different concentration units, ways that you can define how much solute is in your solution, but we're going to be focusing in on molarity because molarity is the most common one that we use in chemistry. It's not the only one we use in chemistry, but it's by far the most common one. All right, so what is a concentration, first of all, before we define molarity? Concentration is saying how much solute, do you have in your solution. You can define it by in the numerator, the amount of solute, and in the denominator, the amount of solvent or the amount of solution. More typically, it's in terms of solution. And in this chapter, as we go through our concentration unit, it will be in terms of solution. So you might want to underline that word there in your notes. So the concentration unit that I'm going to focus in on is molarity, and you're defining the solute, think of that word, the solute, the thing being dissolved, in terms of moles. How many moles do you have? And you're defining the denominator, or how much solution you have, in terms of liters. So we have an equation that we use to calculate molarity, and it would look like this: moles of solute over liters of solution. So you need to commit that relationship to memory. If you want molarity, you have to know moles and you have to know liters. If you're given molarity, you're given moles per 1 liter. Okay, so if you're reading along and something says that this solution is a 3.0 molar solution, and that's how we would say it, molar, what they are really saying when they give you that is that there are 3.0 moles of the solute in every liter of solution. Okay, and notice how I abbreviate my solution there. I'll typically abbreviate it. I might leave off the apostrophe, but I'll abbreviate it there with SOLN. Okay, so let's see what kinds of things we should be able to do with that. Here is a problem. We're going to calculate the molarity of a solution, so we want to know what the molarity is. And it's given us some information, but what I know is if I want to know molarity, if I'm trying to calculate molarity, I must know the moles of solute. And in this problem, they're telling me the solute is sodium chloride. So I need to know the moles of solute, and I must know the liters of solution. If I know those two things, I can divide them into each other, and I will now know molarity. So I start reading the problem and say, did they give me those two things? And as I look at it, no, they didn't give me either one of those. But they gave me information to get to it. What did they give me for the sodium chloride? Well, they gave me grams of sodium chloride. And I know that I have a tool that will take me from grams of sodium chloride to moles of sodium chloride. What is that tool? Well, it's molar mass. So we go to the periodic table and we look the molar mass up for sodium, we look the molar mass up for chlorine, and we get 58.44 grams are in a mole. And then the grams would cancel and I have the numerator that I needed there. And in the denominator, they didn't give me liters of solution. What they gave me was, milliliters of solution. So that's 250.0 milliliters of solution, but I don't want milliliters, I need liters. So milli, I put a 1 with a prefix and what it means with the other. Now, I will quit doing this over and over again, this kind of conversion, because we do it so often. If you have 250 milliliters, you're moving that decimal point over 3 places, and that's how many liters you have. So very often, I will skip writing it all out because I use it so often. But if you can't know which way to move the decimal point automatically, that's fine. You just have to always make sure you do your conversion right there. So that's what the denominator value is. And if I went ahead and took the 5 divided by the 28.44 divided by the 0.250 liters of solution, what I'm left with, there's the liters and there's the moles. What I've got is moles per liter, and the value for this is 0.34 moles per liter, or 0.34, and we say molar. So that is how you calculate a molarity of a solution. Now let's say I'm wanting to make this solution up. I'm trying to make a solution that is 250 milliliters or 0.250 liters, and I want it to have this concentration, so I've got to dissolve the 5 grams into the water. What does that look like in terms of what you do in a laboratory to make this solution? Well, this flask that you see here on the screen is called a volumetric flask. Okay, and each volumetric flask is only useful for measuring one value. This is a 250 milliliter volumetric flask, which means that right here where this mark is, if you could fill it to that mark, you will have exactly 250 milliliters, or as good as this instrument can measure, 250 milliliters of solution. So what you do is you first put the sodium chloride down in there, so you'd put the grams of sodium chloride into the flask, and you add some water, not a lot of water, just some water. And you put the stopcock on and shake it up. The reason you don't want to fill it up to the mark right away is because it's very hard to shake it up and get it to dissolve if it's mostly liquid and hardly any air in there. So with all of this air, it's really easy to slosh around, and so you get it to dissolve a little bit, and then we will once it's dissolved, we'll go ahead and fill it up to the mark right here. So this is the meniscus gets filled right up to that mark, and we've got ourselves at that point, you can run that bubble back and forth a little bit. We will have a solution that is exactly how it's described there. All right, now with defining molarity, what we will now see is that molarity can be used as a tool to convert between two things. This would be moles of solute in a solution and liters of solution. So this will help us get between those two, and I want to show you how to use that as a tool with this example problem. Okay, now let's stay on the computer screen here. How many moles of HCl are in 500 milliliters of this 0.3 molar HCl? Well, we know that we're going to start with 500 milliliters, and that's the same thing as 0.5 liters. Now, as I said, we have a tool that will get us from liters of solution to the moles of the solute. And we'll use that molarity as a conversion factor. So this is the translation right here of that information of 0.3 molar don't write it as 0.3 molar because it really is 0.3 moles in a liter. Whenever we see something like that, that's what it means. So when we take our volume times our moles per liter, we see that the liters cancel, and that will leave us with that we have 0.15 moles. So what I really want to leave you with is this really important statement here with the word great. All right? Whenever you're using molarity in a problem, you're reading a problem and they give you molarity like they did here, what you will want to do is not put it as M in your calculation, but translate that in your problem as moles per liter. That way units are going to cancel the way you need them to cancel. So just from here on, whenever you see that capital M, don't write it as a capital M when you're doing your calculations. Instead, write it as moles per liter. And you could even be more specific, moles of HCl per liter of solution, so you could work the problem. So let's see another example where this is being used. We're going to prepare a solution of a known molarity. We know what molarity we need to prepare, but what we want to do is figure out how much we have to add in order to make that solution, okay? To do this, you're going to want to calculate how much solute you're needing. Now, you don't want to do it in moles. You want to actually do it in grams, because this you can weigh out. You can weigh out the number of grams very easily. So you'll calculate that. Then you'll do as the picture described a couple slides ago. You will put that solid into your flask. This is a volumetric flask. You will add a little water and shake, and then you will keep on adding water until you add it up to the mark of that volumetric flask. So that's how you make a solution, and you'd be doing that in a laboratory for those of you who are in a lab class. Let's see the step one, the calculate part, okay? We're wanting to prepare a solution that's 250 milliliters of 2.0 molar KOH. So let's turn to the light board here and let's do that, okay? Now, the 250 milliliters is, as I said, I won't always do the conversion that you see here, is this many liters. But I don't want liters. I know that molarity is a tool that will get me from liters canceling to moles, and this is moles of KOH. Okay, so this is going to get me from liters to moles of KOH. That's what I can do with this molarity. So I will put the 2.0 moles here and the liter here. And now I have moles of KOH. If I'm wanting to prepare this solution that we see here on our problem, what we want to know is how much of this KOH would I actually have to weigh out in order to get the right amount in there. So we don't want to stop at moles, because I can't count that high. I can't count that many, and I'm not able to divide it out, but I can certainly go to a balance and I can measure out how many grams of KOH that is, and that will tell me how many moles are there. Now, the molar mass of KOH is 56.11 grams in a mole. And now my liters of solution are canceling, my moles of KOH are canceling, and I'm left with grams of KOH, and the value for that is 28. I only know it to two significant figures because that was my molarity. I'm wanting to know two significant figures. So that is how many grams of KOH I need. Now the question says, how are you going to prepare your solution? So you wouldn't just say the answer is 28 grams. That doesn't tell you how to prepare your solution. You're going to take that 28 grams, and what are you going to do? Well, you're going to add water until you make enough to make 250 milliliters of solution. So how would we say that? Here it is. We would dissolve 28 grams of the KOH in enough water to make 250 milliliters of solution. Notice we're not saying you are going to add 250 milliliters of water. Because if you added 250 milliliters of water, you would have more than 250 milliliters of solution. It would go past that mark. So you're just going to keep on adding until you get to that 250 milliliter mark in a, remember, it's a volumetric flask, so it's a big, long, skinny neck that has one mark on it measuring the 250 milliliters. So with molarity, you need to do two things. You need to be able to calculate the molarity. So you need the formula, and then you also need to be able to use the molarity as a conversion tool to get you between volume of solution and moles of solution using that molarity.